Hi everybody, good morning to all. Already we have seen about nothing but inertia. You know that what is inertia? Inertia means nothing but the simple thing is the inability of a body to change its position is called as nothing but inertia. Already you learnt about nothing but types of inertia also. Types of inertia. How many types of inertias are there? 3 types. What are they? Inertia of rest, inertia of motion, inertia of direction. We have already learnt about all these factors. What is inertia and how many types of inertias are there and what are they. Now I am going to tell you about nothing but what is the factor which can affect the inertia. It means the factor which will affect the inertia. Which factors will affect the inertia? So we can say that inertia is directly proportional to the mass. What is this meaning? What is inertia is directly proportional to the mass? It means inertia depends upon mass. Mass increases means inertia also increases. Mass decreases means inertia also decreases. What is this meaning is, I can tell you that. What is that? Mass increases means inertia also increases. Mass decreases means inertia also decreases. Let's see this one with a certain example. Then we can understand more clearly. So you are a person, for example, trying to push a block like this. So it is having maybe 5 kg mass. And there is another person, otherwise you are the same person, who is going to push 3 blocks, each of 5 kgs. So actually now I would like to ask you one question. While you are pushing the first one, block A, while you are pushing the first one, block A, is it easy or for pushing 3 blocks at a time is easy? So pushing one block is easy. Why? Because it is having nothing but a lesser mass. If it is having lesser mass means, so it is having lesser inertia of rest. So you can push the block easily. So here you are having 3 blocks. So it is having higher mass. Total 15 kgs mass. So it is having higher inertia. So it is very difficult to push the 3 blocks. So this can say that mass is directly proportional to the inertia. Let's see that. This is an example of inertia of rest. Let's see about nothing but inertia of motion example. For example, there is a bicycle which is coming across to you and you got an accident to the bicycle. And there is nothing but one big vehicle which is coming across to you and got an accident. In which case, whether in the case of A or in the case of B, who will get nothing but more injuries or death? So Mr. B will get more injuries or death. Behind this one, this is very simple. Because both are in motion, but which is having more mass? This vehicle is having more mass. So it will impact nothing but more on the person. So this can say that. So the heavy massive body is having, what is that one? Greater inertia. Okay. So this can say that the mass of a body is nothing but directly proportional to inertia. Let's take one example which was given in our textbooks to solve a problem. So there is a block which is placed on a table, this it, in a horizontal table. Now they are actually applying some force. Applied force always denoted with capital F. So how much force is applied means force SI unit is newtons. So 10 newtons force is applied by a person on the block like this. Now the block is moving in this direction, let's hope that. So there is a force which is opposing the motion of this block, which is called as frictional force, acting opposite to that direction. Now they are asking that calculate how much amount of frictional force is acting on the block if the block is moving with constant speed. Constant speed. Constant speed meaning is nothing but a uniform motion. So they are asking you to draw the FBD also. It means free body diagram. Let's draw a free body diagram in this case. Let's take this block here, and now we want to say that there is a force acting in this direction, applied force 10 newtons. There is a frictional force acting, we don't know how much is this. This is horizontal direction forces. Let's see about vertical direction force. Actually there is a table. Down means upward, which force acts? Normal force. Downward, which force acts? Gravitational force. Gravitational force is denoted with W. Normal force is denoted with capital N or sometimes R also. And now actually the question is, they are asking you to calculate nothing but a frictional force. That means while we are doing the sums, we have to divide that one horizontal forces and vertical forces. So that is the reason why here we have to calculate only the horizontal force of frictional force. So that's why I am going to take only these two forces. I am not considering the normal force or gravitational force. So they have given a hint to us. The body is moving with a constant speed. It means uniform motion. You know what is the first law of motion? If a body is at rest, it wants to be at rest. If a body is in motion, it wants to be in uniform motion unless and until an external force acts on the body. By this first law, we can say that if an object is at rest, then automatically the net force acting on the body is equal to 0. How much? Net force equal to 0 if a body is at rest. If a body is at rest, in which case Newton's first law. So Newton's first law second part, if a body is in uniform motion, then also net force equal to 0, because if all the forces acting on a body, the sum of all the forces acting on a body is equal to 0, then the body will move in uniform motion, otherwise at rest. Let's see this. Here in this case, the body is moving in uniform motion. So horizontal forces we are calculating. Horizontal forces. What are the horizontal forces? Applied force 10 newtons and frictional force we don't know. We know that net force acting on a body, the body is moving in a uniform motion, net force equal to F net equal to how much? 0. Net force means sum of the horizontal forces. What are the horizontal forces here? So if you consider that this direction is positive and opposite direction must be negative, so the direction force is applied force, opposite direction force is frictional force. Therefore plus F minus F, that is the net force, that is equal to how much? 0. You know that applied force how much? 10 newtons. Therefore we got plus F minus F is equal to 0. So applied force how much means 10 newtons minus F equal to 0. Therefore 10 newtons equal to plus F. What is this small f? Small f means which force? Frictional force. What is the meaning of this one? If a body is moving in uniform motion, then the applied force, capital F, is equal to frictional force. What is that one? Small f. This is that if a body is moving in uniform motion, we can say that the applied force is equal to the frictional force. Thank you.